And we're back, mathematicians. We're live. We survived climbing in the mountains. Saw a bear, but we were already in the car at that point. A grizzly bear. Those things will kill you. Yeah. But we didn't die. None of us died. At least not on the hike. Who knows what's happened in the last 12 hours. Yeah. Okay. Oh, you need my help. Okay, what do you need my help with? Let me know. That's what I'm here for. You have a business proposition, but I have to send you $1 million to even hear the proposition, Boris? I mean, I don't have $1 million to send you, so yeah, that's tough. Okay. You figured out your Laplacian problem the other day. More specifically, you stopped being a wimp and wrote everything down in local coordinates. Well, yeah. I feel like that's so often the answer, Like, I feel like so many times when I'm tutoring people, I'm mentoring people, even for myself, it's just like, oh, I'm stuck on this problem. Did you try to just, like, write it down? Oh, but, I think that'll be, local coordinates will be messy and hard. And it's just like, yeah, just write it down. And then, of course you write it down and it solves itself. Apparently, comparing those Laplacians leads to some really interesting topics. Oh, interesting. Bachner's vanishing theorem. Oh, interesting. Let's take a look at that. Bachner's formula? That's like an integration identity, I thought. No, I'm thinking of the Bachner theorem. Woke up even earlier today. Wow. Good morning, Ken. Good morning, Ken. You're going to catch the full episode. I don't think it'll be a long one today, but who knows? Yeah, this is not the other Bachner identity, I know. Okay, this doesn't seem like a vanishing theorem, though. Or is it? There's something here. If U is harmonic, where that is the Laplacian with respect to G, I see. Then Bachner's formula becomes this. Interesting. Oh, Bachner's vanishing theorem, non-existent link. That is tragic. Yes, Dason, I can confirm that is true. Yeah. I can confirm that is true. I mean, yeah. Basically, you start doing homological algebra and you see that it works here and you see that it works there, and then you ask, well, what are all of the places that exist? And then you, and by you I mean, I guess, Grothendieck in his Tohoku paper comes up, you come up with an axiomatic formalization. You say, okay, well, what are the properties that I need to make a cohomology theory work? Well, I need kernels, I need co-kernels, you need additivity. You should write a wiki article, Rad. Definitely. Yeah. Okay, so I think I promised Zhongshu that we would do some Tor computations. Oh, this is about the Dedekind piano. Is it piano? I've never known. But you know what? We've got the wonderful Google how to pronounce piano.
Pinot.
Pinot. Okay, it is Pinot. That's what Google suggests anyways. Pinot.
Pinot.
Pronouncenames.com. Let's try that.
Names.com.
Piano.
Piano. Oh, okay.
Piano.
I trust this more. I trust this more than Google. A random thing from 11 years ago about Italian names. Piano. Yeah. Actually, I should ask my Italian friends. What's the point of having Italian friends if you can't ask them that stuff? Lola, that would be very helpful, but I don't necessarily know what the accents are how you're supposed to pronounce them. But there is the apparently. Sorry, Matthias, I'll get to your question in a second. But apparently, what was I saying? The English or the international phonetic alphabet, if you really understand it, you can basically pronounce anything on the first go. Like there was a friend of mine was telling me about a language course they took, and then at the end of it, or maybe at some point during the course, the professor was like, okay, like all of you write your names in the way that you say it in the phonetic alphabet, and then he like said them all correctly on the first go or something like that. Oh, Tahaku's about sheaves. I see. Okay, yeah. Okay, anyways, what is this question? Let n be a natural number with n not equal to 1, and let S be the set of natural numbers not equal to 1. Suppose n is not in the form m to the power of plus? I'm not sure I understand your question. Is that supposed to be the successor? Is that a notation for the successor function? So suppose why is this being weird? Whoa. Uh-oh. Whole screen freaked out for a second there. So suppose n suppose for all m in n, n is not equal to m plus, which I'm guessing is successor. Yeah, okay, you said successor, yeah. Prove that if r is a natural number, then r plus must be a natural number. Okay, so that's weird the way you've stated it. I don't see, like, your whole setup with this and with forming the set. With this set, I don't see what that has to do. Like, you have the claim that, R natural implies R plus natural. I mean, no part of what you've written here seems to have anything to do with the above. And also, isn't this just one of the axioms? Like, don't we just assume this to be that this is just one of the axioms, right? So yeah, that's just one of the axioms. Strongly believe names should be pronounced in their respective languages. I've gone back and forth on this. For a time, I tried to make more of a point to say names more correctly, but so yes, but also, I don't know, language is highly mutable and constantly evolving, you know? Like, it's interesting, sometimes I get bothered by misuses of language. For example, people misuse begs the question all the time, and there's certain people around me who do it almost on a daily basis. And there is a certain part of me that's bothered, but then I'm like, well, language just constantly evolves, right? The meaning of phrases change over time, and new things get invented and old things get forgotten. So, yeah. Doing a Riemannian geometry course for fun. Nice. I like your concept of fun, Boris. After years of categorical nonsense, and the notation is killing you. Yeah, I mean, differential geometry's got some crazy notation. It's just weird. I don't know how things work out like that. But well, Matthias, maybe if you I don't know, if you can let me know where this question is from, if you can give me an exact reference, like the textbook, page number, question number, something like that. Yeah, I remember once trying to read the Tohoku papers in French. I had the English translation and French translation, and was trying to like help teach myself math French by going between them. Just went for a run and feel like $1,000,000. Hell yeah, tenacity. That's what we like to hear around here. We like to hear that people are going for runs and working out and maxing your VO2 max. I had a long, actually no, not a long, relatively short hike in the mountains yesterday. And definitely tomorrow's going to be a VO2 max day. For sure. Talking about deltas and nablas, or the even worse index notation. Stickler for Einstein notation. That feels so finicky. Yeah, but it's also nice and just writing all these sums. Good question. Cockupsy. Coopsy. Sorry, I don't know. We were just talking about pronunciations. Are we talking about linguistics or mathematics? It's always a question I'm asking myself. What's the difference? I mean, this is a math channel. We are mostly talking about math, but hey, linguistics is important and intersects. There's the linguistics of mathematics, and there's also the mathematics of linguistics. So yeah, always on my Wittgenstein arc. Although I've really only, to be honest, I've almost read, like I've read basically no Wittgenstein, any of his official works. I'm just aware of his ideas and I like them. Well, this is a safe space for finitists, Boris. You're welcome here. Kokusai. Kokusai. Or Koku, if that's easier. Sure, yeah, I will. Well, Kokusai. I think if that sounds correct enough, then I can say that. Yeah. But if I'm still butchering it, then maybe I'll just stick with Koku. Yeah, sorry about that. Good morning, Rubik's. Okay, so where are we here? Well, I don't think Zongshu is in chat, but have I ever read Baby Rudin? And do I think it should be a must read? That's an interesting question. Yes, I've read Baby Rudin. That was my first analysis course. And good morning, Paul Maurice. It was my first analysis course, and uh, it's also like the book that analysis at my current university is taught out of. Um, and yeah, do I think it's a must read? No, not necessarily, but it has just like there's oh yeah, pronouncing it right. Awesome. But there's arguably other books that are easier to understand, more friendly for beginners. But it's just sort of somehow inserted itself into the culture and become the dominant text. And so I'm continuing to perpetuate the use of this text. Like one of the people I'm tutoring right now, I recommended to him to start reading Rudin. But I said, hey, look, if you find Rudin, too complicated, or you're just not connecting with it, then we can find another book to work with. There's ones that have more visuals and examples and stuff. But yeah, so I don't know. We're making an attempt to perpetuate the use of Rudin. I like your plan, Boris. Learning to spell through Rudin. Yeah, that would be, if I ever had kids, we would read that on Sunday mornings. That would be our church, our Bible. Read it to them before they go to bed every night. And some growth and deke. All right, I'm gonna look at my Discord messages on my phone. Is that crazy? Is that totally crazy? It might be totally crazy. But it's taking forever. Baby growth and deke equals EGA 1 to 4. Yeah, probably. Well, Matthias, yeah, so one thing, of course, ChatGPT is, I've been pretty good, Laura. I've been pretty good. Thanks for asking. How have you been? The one thing about ChatGPT, good for translation often, but, good for translation often, but you never know where it's going wrong, so, yeah. In the following, one must take as a starting point the description of natural numbers given by the axioms in JPH. Okay, well, what's JPH? Can you tell me what that is? Because that seems critical to understanding this problem. Oh, okay. So I see. Okay, so there's some missing parts of the explanation here. So S is defined to be this for n not equal to 1, and we want to explain why. So we want to prove that 1 is in S. We want to show assume that for all m in n, m plus is not equal to n. And okay, so again, here's some important context that was missing, Matthias. If S is if R, and then we want to show if R is an element of S, then R plus is an element of S. Why is this conclusion impossible? Okay, so that's okay. So maybe we'll put exclamations around this. Strangely worded, but that could be ChatGPT's fault. We want to explain why this statement is false. Okay, so the important context missing there is the set we're talking about is S, not N, right? And we want to talk about why this is false. And then explain why there exists an M such that, yeah. Right. So so it's this one that you're stuck on, right? Well, that's right. So what do we need to do? We need to explain why this is false, right? So I see. Well, yeah. So I think the point is you just need to show why this is false, why this statement is not true, right? So we need to provide a counterexample. Well, what's the negation of this statement? Is that there exists R in S such that R plus is not in S. Okay, so if this is true, we need to pick an R that will make this true. So how could we possibly do that? Let me go back to the setup here. Yeah, actually, hang on a second. This still, I don't know. Maybe you should just ask your instructor for clarification because, yeah, again, there's the same problem. It seems like, oh no, okay, maybe this is fine. Maybe this is fine. Assume that M is not of the form M plus. Yeah, the wording, I don't know. The wording doesn't really make sense. The wording doesn't really make sense because I think we can if we take this assumption, then I think we can prove this follows. But if n is not of this form, then this won't be true. So yeah, I think maybe you just need to ask your yes, if n is, I mean, that's the way we should be thinking about it, right? If n is not a successor, it should be 0. So yeah, just ask your professor for clarification. Yeah. Yeah, I do not understand the proof of singularity resolution. You've been seeing me in my suggestions. Didn't expect abstract algebra to pop up here. Really? I feel like that's all we're ever talking about here is abstract algebra. Do I think it's okay to use ChatGPT to convert handwritten homework into LaTeX for submission? Well, yeah, it doesn't sound like a bad idea. I mean, obviously, go through everything and check, edit things and check for errors and whatnot. But yeah, why not? That sounds like a great idea. If you've got everything written out by hand and it can, do like even an 80% approximation, yeah, I don't see why not. If yeah. And if n is 0, then n minus 0 is closed undertaking successors. Yes, exactly, Rod. Exactly. And then if it's not, well, then it won't be. If n is not 0, yeah. How is 0 defined? Do we even define, 0. We say that there is a natural number. There is something that is not right. The constant. Okay, right. So we give a symbol 0, and the axiom states that the constant 0 is a natural number. Right. But then is there an axiom that says 0 is not the successor of anything else? Right. Yeah. Right. So we have an axiom. Yeah, we have an axiom here. But it's interesting. I don't think I don't think that there is an axiom that says this is the only number that satisfies it, right? Maybe there is. Maybe you can prove it. But, yeah. But I know, for instance, like in the set theoretic construction, we assume the existence of an inductive set, and then build the natural numbers out of it. Yeah. Silly question. All of math is silly, so tautological statement. But you've wondered, for homology, we consider maps whose images lie in kernels of the next ones. What about the complementary notion, where we consider maps whose kernel lies in the image of the previous? Well, let's take a look at that. So what would that look like? So, yeah. So say we have A, B, C, G. So you want the kernel of G to lie in the image of F. That's what you're asking? So I think there is a simple answer for why it's not considered. Oh, Rod, maybe you just said it. In this case, we can always restrict the first map to ensure its image equals the kernel. Yes. Wait, is that true? Right, we could restrict F. We could restrict F to do that. Yeah. Yeah. Is that the reason? I guess so. Yeah. I mean, I guess the other way to think about it too is like the other way that we conceptualize it is it's always about like a double composition. I guess it'd be this way: some double composition being 0, right? Which has a very natural formulation, and I don't know if this would have like this conditions as natural of a formulation. Yeah, exactly. Yeah. On that note, by the way, on that note, we talked about. I wanted to get back to Tor. Oh, it's already 9. Well, Zongshu's not here today, anyways, so. I will push back Tor even further. We'll talk about Tor on Tuesday. Tor Tuesdays. How about that? Tor Tuesdays. Yeah. I'm gonna end office hours here. I gotta get to work. I got a lot to do. It's August 18th already. That's. I gotta get writing. I gotta get grading. Actually, that's what I need to get doing. So I will see you all tomorrow for Tor Tuesdays.